Hello, cherished learners. Welcome to today's lesson. I hope you enjoyed our previous lesson on Introduction to Variation. Not far from what we learned last week. This week, our topic for discussion is direct variation or proportion. At the end of today's lesson, you will be able to understand when two quantities are in direct variation. Conditions for two quantities to be in direct variation. To find out the missing quantity when two quantities given are in direct variation. How to find the variation constant K. Applications of direct variation in day-to-day life. Let us consider some real-life situations. A family of 4 members consume 2 liters of milk, whilst a family of 6 members consume 3 liters of milk. We can see that as the number of members of family increases, the consumption of milk also increases. Let us consider another real-life situation. Justice bought 8 pence for 8 cedis, whilst Albert bought 4 pence for 4 cedis. We can also see that as the number of pence decreases, the cost also decreases. So then, what can you say about these two situations? I guess what you are thinking is right. We saw in the situations above that changes in one quantity resulted in changes in the other quantity. Then, if two quantities are so related that an increase or decrease in one quantity leads to corresponding increase or decrease in the other, then two quantities are said to be in direct variation. Let us consider another real-life situation. A car uses 4 liters of petrol to cover a distance of 60 kilometers. By unitary method, we can find the number of 8 liters of petrol, which is 120 kilometers. The same happens to the 12 liters of petrol, which would be 180 kilometers. We can also see that the ratio of petrol used to the distance covered is the same, so it is constant. Let petrol in liters be x and distance in kilometers be y. As x increases, y also increases. The ratio of x to y is constant. K, which is variation constant or proportionality constant. We can also say that x is equal to ky in simple mathematics, where k is proportionality constant. Let's take another example. If 1 pen costs 2 cedis, 2 pence will cost 4 cedis. 3 pence will also cost 6 cedis. The number of pence to the cost of pence. Let the number of pence be x and the cost of pence be y. As x increases, y also increases. As x decreases, y also decreases. This means x varies with y. To replace the proportionality sign by an equality sign, we have to introduce a constant k, called the constant of proportionality. Also, if y varies directly as r cubed, you have y is equal to kr cubed. If y varies directly as x, this implies as y increases, x also increases, such that their ratio remains constant. The graph of such relationship is shown below. Let's take an illustrative example. The length of the shadow of 3-meter high pole at a certain time of the day is 3.6 meters. The height of another pole whose shadow at the same time is 5.4 meters. Let's show this in a table form. Let the required height be x meters. And we know that the ratio of shadow to height of the pole would be the same. Then we have 3.6 over 3 is equal to 5.4. over x. Using cross multiplication, you will get 3.6. X is equal to 5.4 times 3. Then x is equal to 4.5 meters. Let's take another example. A car travels 330 kilometers in 5 hours with a uniform speed. How many hours will it travel in 4,290 kilometers? Let the required time be x hours. 330 over 5 is equal to 4,290 over x. You get 330x is equal to 4,290 times 5. Then we have s is equal to 65 hours. Don't you think we also have another method? Because we already showed that d is equal to 330 and t is equal to 5. Then we have 330 equal to 5k. According to the formula, d is equal to kt. K is equal to 330 over 5, which will give us 66. Then d is equal to 66t. Then t is equal to 65. Now, I want you to try your hands on this question.
A worker is paid 639 cedis for working for 6 days. If his total wages during a month is 2,769 cedis, how many days did he work for?
I hope you've gotten the concept for today. Let us summarize the whole lesson. Today, we've looked at when two quantities, x and y, are said to be in derivation. If the increase in one other causes the increase in the other, or the decrease in one another results in the decrease in the other, then x and y varies directly. Thank you.